Stop talking. Freaking loud in here. Sine is your nemesis? First, we're going to graph sine. What is the sine of negative pi? Zero. So negative pi is 180 degrees this way, and you want the y value, so that's 0. What's the sine of negative pi over 2? Negative, I know it's a good question. Sine of negative pi over 2 is down there. Negative 1. Did you say negative 1?
Yeah. Well, I said 1 at first, then I said negative 1.
Sine of 0. At 0 degrees, what's the y value? 0. Sine of pi over 2? 1. You can see the pattern, right?
I hope so.
So it turns. So that's the graph of sine. Now let's graph the derivative. The biggest the slope ever gets is 1 and negative 1. So like right here, that's the steepest that sine graph is ever going to be. The steepest slope that it gets to is negative 1. So the slope right there, like if I drew that surfboard, you know, that surfboard have a slope of negative 1. What's the slope of the surfboard at this x value? 0. Because that surfboard will be flat, right? What's that slope? 1. What's that slope? 0. And that slope's negative 1. If you connect these, that's cosine. So if I give you y equals sine, then your derivative is cosine, which we already wrote on the board, like we already talked about that. I'm just kind of showing you why it is that. And then sometimes you get stuck. Like I remember being in high school, like I don't remember sine and cosine, which one to do with negative. Like I knew one of them was, but I couldn't remember which one. So I just did this. Like I figured it out myself. Like, okay, that makes sense. It's positive. So if you get stuck, you gotta have something to look back at. So if we go the other way, so let's say y equals cosine of x. So let's graph that, and then graph the derivative, and see what we got. So right now I'm just graphing cos. I'm not worried about slope or derivative or anything. Just what is cosine? So let's start at 0. What's the cosine of the x value at 0 degrees? 1. This is me going like rotating this way. So what's the cosine up here? 0. What's the cosine over there? Negative 1. This is 0. This is negative 1. Cosine looks like that. And then, I mean, it just wiggles like that or whatever, right? I'm just looking at like a small picture of it. Let's look at the slope. What is the slope right there? That levels off, right? So that's 0. The steepest it ever gets is 1. So that slope is 1. What's the slope right at x equals 0? 0. Slope here? Negative 1. And then 0. So you can see that's not sine, because sine goes down and then up. It's the opposite of sine, because it goes up and then down. So the derivative of cos is negative sine. Who's yawning? This is like the most exciting thing you can possibly have. The derivative of cos, you don't think that's just enthralling?
It is very, it is.
You yawned twice.
I've never even heard the word enthrall.
But it is actually a pretty good word though.
It is.
A+.
So, when it gets right down to it, all you gotta know is the derivatives. I'm just trying to help you understand where they come from. Let's look at tangent.
Oh, this is
What is tangent? Sine over cosine, good. So that's sine of x over cosine of x. If I ask you to take the derivative of that, what rule should I use? Quotient rule, right? Yeah. That's a fraction. So what is quotient rule? Flip it.
OD high minus ID high.
ODI minus IDO, or 2D1 minus 1D2, or bottom derivative of the top minus top derivative of the bottom, like whatever way you want to think of that. Divided by the bottom squared, right? So it's going to be the bottom times the derivative of the top. What's the derivative of sine? Minus the top times the derivative of the bottom. What's the derivative of cos? Negative sine. All over cosine of x squared. Well, if I go to simplify that, this is cosine squared, right? Do you guys know that these two things mean the exact same thing?
yeah.
We've talked about that last year or some point, whatever. Okay.
Yeah, and you mentioned it could be
Correct. Plus, right? Because negative, negative. Plus sine squared. Agreed? Can I cross off those cosine squareds?
No.
Thank you. So that, again, that would be like saying 5 plus 10 over 5. I can cross those off and just be like, yeah, that's 10. Doesn't work then. But there is something I can do. Shut up. What is cosine squared plus sine squared? 1. So I guess you didn't show. I know we talked about it last week. That's the Pythagorean theorem. The cosine squared is x values, sine squared is y values, so you get the x and the y of the triangle, and then the hypotenuse of that little triangle is 1. But you gotta memorize that. You gotta know that. Cosine squared plus sine squared equals 1. That's a thing. So it's 1 over cosine squared. Can anybody rewrite that for me? Secant squared, good. So the derivative of tangent is secant squared. Which process?
I just feel like all of them are going to be really hard to remember.
Well,
It's going to take a minute.
This won't be given on a any sort of sheet.
God. There's going to be 15 of these by the end. There's 6 trigs. There's 6 trig inverses. There's the derivative of like sine inverse, cosine inverse, secant inverse. Then there's 60. Then log, natural log, e. Maybe it's 50. Anyway.
Then you'll find the 16.
Maybe I can pick one up somewhere. That's 3 of them. Questions on this one? Because I'm going to have you find cotangent.
Why?
Same process. What's cotangent? Cosine over sine. Do the same thing.
Wouldn't that be just the same?
I don't know. Find out. So if I have cotangent, I want to know what the derivative is.
Oh my gosh. We should have did a quick
cosine over sine, right? So go through that same process and see if you can tell me the derivative of that. You'll have to say never mind when you talk. Whatever that is anyways. Well, right.
Did you like bully your teacher in college to giving you your degree? I can see that. Wow. You, what did you do? You push and roll them? No, chain roll. That's what it was. Did you chain roll your college teacher?
I don't know. Just something. It's really similar to the last one, but there is a little bit of a twist with some negative. There's a negative issue. Drew smells I'm stepping in. You smell I'm stepping in? I really don't want to. Maybe it was a delicious fog. You just assumed it was crap.
Well, if you're stepping in,
I couldn't step in something that smelled nice.
yeah, but if you're stepping on something that smells nice, how do you step on it?
Fair enough.
1 over sine.
What is 1 over sine?
Yeah.
Cosecant.
Cosine.
So, quotient rule says the bottom times the derivative of the top. What's the derivative of cosine? Negative sine. Minus the top times the derivative of the bottom. What's the derivative of sine? Positive cosine. Over the bottom squared. So this becomes negative sine squared of x minus cosine squared of x over sine squared of x. And again, can I cross out the sine squareds? No. But what I can do is pull out a negative 1. And then what would be left inside of that is sine squared plus cosine squared. Agree?
Yeah.
That's like the little trick. And then what's sine squared plus cosine squared? 1. So this just says negative 1 over sine squared. And how can I rewrite that so it's not a fraction?
Negative secant squared. Or cosecant.
Negative what?
Negative cosecant.
Negative cosecant squared. So negative cosecant squared. Everything that starts with a C, well, I got 2 so far, but there's one more coming, has a negative derivative. So that's like a little tip to help you remember it. Cosine had a negative derivative, right? Cotangent has a negative derivative, and cosecant will also have a negative derivative. So if it starts with a C, your derivative is negative. Alright? Questions there? Okay. It wasn't really a question.
Like a demand.
It was
It
a
was.
request.
It felt demanding.
Yeah.
She's gonna chain roll you. I should remember the answer.
No, I'm seeing if you guys know enough to work through it. I'm saying. Let me know, Homer.
It's my own. I'm sorry.
Yeah.
So, just to refresh is the graph of cosecant inverse graph of sine? Sine upside down.
The inverse is different than the upside down.
Well, yeah.
But yes, the inverse. But the inverse is like flipped over that y equals x line, whatever you remember that.
Yeah, that's what I was talking about.
Yeah. Okay. So we have 2 left. Let's say y equals secant of x. What does secant mean? Secant is 1 over cosine. So I could do this 2 ways. I could do quotient rule from there, or I could bring the cosine up and do chain rule. I don't really care. Does anybody have a preference? Quotient or chain? Quotient? Okay.
Just keep rolling.
Alright, we're going to have to vote.
No, just
Raise your hand if you want quotient. Raise your hand if you want chains.
You
You weren't even. You know neither of them are.
That's why I want to be here so I can see it.
Well, maybe we'll do both. We'll do both.
We should probably do chain rule.
Why?
It seems like there's quite a bit of people who don't know how to do chain rule.
Yeah, Mr. Davis, do one of each. Just do
I'm gonna do both. Yeah, I just had the revelation. Quotient rule would say the bottom times the derivative of the top. What's the derivative of the top?
0.
Minus the top times the derivative of the bottom. What's the derivative of the bottom?
Negative sign.
Over the bottom squared. Well, that just goes away, right? And we get sine of x over cosine squared x. I want to rewrite that. Well, first of all, the question that gives me. Second, I want to rewrite that so it's not a fraction. How can I do that?
Could you split the cosine as cosine times cosine, and then sine times sine over cosine is tangent, then 1 over cosine or secant.
Do you agree with this? This step? Cosine times cosine on the bottom is cosine squared. Sine times 1 on top is sine. And then I can rename both of those. What is sine over cosine? That's tangent. What's 1 over cosine? Secant. So the derivative of secant is tan x sec x. Got a little carried away with my box. A little excited. I want to do that with chain rule too. Just to make sure that was quotient.
Oh, yeah, that's
Questions? Pile, do you agree that it was quotient?
yeah.
Alright.
Wait,
Yeah.
wasn't done writing.
I can't really go back.
There's no one do it.
Alright. There's what?
There's no one do it.
I don't know. Drew, does that help you?
No, I was past that. I just needed the final. Go like this.
Just read the
Why?
book.
Are you like?
Erasing it slowly or?
Well, I don't want to erase the whole thing.
Oh, gotcha.
Okay, yeah.
Okay, chain rule. What I would do is take that and bring it up. So on the bottom, let's go to x to the first. So on the top, what is it? Cosine of x to the negative first. So I can rewrite it like that. Those are the same thing. There's really like a 1 in front. This one is this one, but I don't really need it. And then I'm taking the cosine and bringing it up, so I change the sign of the exponent. The SIGN. So chain rule. What's the big guy here? Negative 1. What's your little guy?
Cosine.
Cos. So we take the derivative of the big guy first. So the way I take the derivative of powers is to bring it down, reduce the power by 1. What do I do with Mr. Packer?
Leave them alone.
Leave it alone, and then I multiply by the derivative, which is negative sine of x. Now I want to rewrite that. It's kind of a goofy process here because I don't want negative exponents. So like the first thing I'm going to do is bring this down. But then I'm going to say I don't want to write it as a fraction, so I'm creating a fraction in order to get rid of a fraction, which is weird. But all I did was multiply the negative 1 times the negative sign, that's positive sign. And then the cosine of x to the negative second goes to the bottom, goes to the second. It's okay? And then I split it up just like we did a second ago. So this becomes sine of x over, sine of x over cos times 1 over cos, which is tan times sec, which we already knew. I'm just getting to it a different way. You can use quotient, you can use chain. So why?
Oh, I'm just tired. I thought I want to make this as
Good? Alright, you good. Can I erase? Okay, you guys do cosecant.
This is the last one.
This is the last one for today.
Okay.
quotient, or if you want to try both, try both. Cosecant is 1 over sine.
That's why it was. That's why it was believable.
You know what? Get out of here. I'm actually just doing my work.
I know, you're totally fine right now. I'm sorry to bring you in.
He doesn't hate you right now.
I'm sorry you got dragged into all this.
I know. I'm actually doing my work.
You have to say I'm actually doing my work.
Right, that's a problem.
I'm just saying it's sad.
I usually do my work. I just talk with idiots that way.
You usually do your work in class.
Yeah.
Not so much with the homework.
I was going to talk to you. I did. I forgot. I don't have an excuse. I'm sorry if I was making an excuse. I just let myself forget.
I mean, I'm not, it's your grade.
I know.
I'm not mad.
I know. I am.
That, I can
I
understand.
walked into school this morning, and then I opened my Chromebook at NCIS, and I saw it up, and I was
It was,
like, it was like baseball. I was frustrated with myself. Do you accept it, or no?
you should do it because it's
Yeah, I'm gonna do it to you.
Yeah. So he made the cosecant negative, you made the cotangent negative. Doesn't matter.
Oh, that's what's fine. Oh,
They would all multiply together and end up being negative. Do you have the quotient or chain?
Cotangent is
Quotient.
cosine is cosine of sine, right?
Yeah. How many did quotient?
Oh, yeah, she got one.
How many did chain?
Someone did change.
I did change.
I don't know. I think chain's probably shorter, but it's probably harder for most people to understand. So I don't know. I'll do both if you want. I'll do quotient first, and if anyone wants me to do chain, I'll do that too. So cosecant's 1 over sine, right? So the derivative would be the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom over sine squared of x. So that just becomes negative cosine of x over sine squared of x. And then that becomes, okay, so the negative can go in either spot you want it to. So if I put a negative here, or I put a negative here, it's the same thing. I'm going to put it there, and then this would become negative cotan, and this would just be cosecant. But I could have just as easily said negative cosecant times positive cotangent. It's the same thing. So that would be your derivative. Negative cosecant times cotangent. So I put it over here. This list, so this list is only 6 things long right now. There's going to be more. But it is fair game for me at any point from now on, from now until your AP test, to say stop, put everything away, I'm giving you a quiz on those. I would erase it first round. But starting tomorrow,
Would you leave those up for like a test?
I will not leave those up for a test, because they're not on the AP test, you don't get them there either. So starting tomorrow, at any point, I can be like, clear everything off, 6 question test, I'll do worth 6 points, which isn't a ton of points, but every little bit can swing you one way or the other. What?
Can you like promise us that you won't do it like tomorrow?
I
Give us like a
cannot.
chance to study these at least.
I cannot promise you that.
He's doing.
There's 6 things, you already know 2 of them, so there's 4 things. You're telling me you can't memorize 4 things by tomorrow?
Who said I had the other 2 memorized? I just always look at the board.
David, that's a you problem.
Are we gonna have to test more?
It is a
We
beauty.
could.
Class.
Oh.
Can't have it.
So
Wednesday on.
No. What is it?
Got
Just
that.
gonna walk
So
in
can
all
you
of our,
promise
like,
us now that you
other
will
classes?
I suppose I can promise you.
Oh my god.
And
Next day,
you just
though.
walk into all of our like third hour classes and it's a
Let's
test and be like, I
combine
said it
that.
was fair game.
Yeah.
Walks into Packard's class. Packard's like, what are you doing? He's like, I'm here to give them a stat, a calc
Just
test.
walks up
He's
to
like,
the marker.
this is
Do this
is
now.
lit.
No, you can try that.
This is not lit.
To be honest, if
Why you decide to find the derivative of that?
Wait, I know how to do this. Wait.
Birch, how you doing?
I was fine with that number.
so the other one I post, right? Post. Yeah.
Is this right?
Yeah. Is this right?
Negative sign, right?
So,
Oh, is it like a big little guy?
what rule do you need here?
Change.
How do you change?
Yeah.
So your big guy, please stop talking when I'm talking. Your big guy is coast, so you take the derivative of the big guy first. You leave the little guy alone, and then you multiply by the derivative of the little guy. So that should be your answer.
Okay.
Somebody had that? Okay. And if you didn't, I'm guessing you just forgot the chain rule part of it. Yeah.
So I've made it negative 32x cubed times sin x. Is that still fine?
Oh, you distributed in like those?
Yeah.
You can't do that because this is being signed, and this is not, so they're not like transferable. Yeah. Oh, okay. Shh. Alright, let's say sec of x squared. So this is a little bit different. I just want to show you what happens when you have, because the derivative is like two parts, right? So what's the derivative? So what's the big guy? Sec. What's the derivative of sec?
Tan x.
It's sec of whatever, tan of whatever. So what do we do with Mr. Packard in both of those spots?
Leave him alone.
Leave him, and then we just need to multiply by the derivative of x squared. So we're just putting 2x out there. You're not putting like another one. The derivative of sec is sec tan. Leave the little guy alone in both of those spots. And then just multiply by the derivative of x squared out.
Imagine if you have to derive that, like you have to get that derivative by calculations on the test.
Do that. Yes, but I'm gonna give you 2 to do. Easier to walk around. What's the derivative of tan? Leave the little guy alone, multiply by the derivative of the little guy. How many have that? What's the derivative of negative cosecant?
Cosecant
Positive cosecant.
times negative cotan.
No, they both positive. Yeah.
So cosecant becomes negative. Cosecant cotangent is like 1 unit, and it's either positive or negative. So a positive cosecant derivative is negative cosecant cotangent. A negative cosecant derivative is positive cosecant cotangent. What goes in the parentheses? 8x, and then what do I multiply by? That's it. How many have both those? Okay. Yeah.
Like the first one, I brought 4 to the front and I said 4 secant squared 4x.
Yeah. So the problems that I give you are just this. Like, there's nothing hard in it. It's basically helping you memorize them. It's not the whole the main point of the assignment. So there's like 20 on here. The little guys are all really simple. So the chain rule part is not going to be complicated. It's just basically having you practice those 6 rules so you can get them in your head a little bit. And then tomorrow, Wednesday, we'll start doing like product rule with Trig, quotient rule with Trig, chain rule, combining rules.
Is this like what our quizzes are doing? Or what are their rules then?
If I give you a pop quiz, it'll just be straight up those 6 things.
Okay.
There'll be no math involved. It's just a memorization quiz.
So let's just say with 16, it'll be like each one is one of the rules. Like you'll have one product rule, one with quotient rule.
Product and quotient won't even be on there. It'll just be what's the derivative of sine, cosine, cotangent, secant, cosecant.
Question.
Just no math.
Or
Memorize.
you Twitter.
I
Oh my god.
yeah, I just did trade cards.
So it's okay you don't have them memorized.
Will we still have enough time to be able to like
No. On the memorization quiz, you'll have like 2 minutes. So you won't have time to do what we just did. I want them memorized. Not like I can work them out if I have half an hour. Because you don't have that time on the AP test. You won't have time to derive them and then do the test also. So your memorization question quiz will be timed before the test. Let's work, please.